Here is integrated 310.3.2. It's triangle and the binomial theorem. It says in this lesson you will use something you learned when studying probability that has a support. Work with your team to complete a table for combinations like the one below. Discuss any patterns you notice as you are working. So they give you this table. It's partially finished. You might already notice there, it seems like there's some ones going along down here. Having trouble with the lighting here. So let's try to figure out where these numbers come from. It says n, the total number, r, the number of choices. So they want you to take combinations here. And if you remember, combinations are, there's a formula for combinations. The combination of n things taken r at a time is n factorial over n minus r factorial times r factorial. So, for instance, if I want to take the combination of 4 things taken 3 at a time, 4 is the n, so I'd go 4 times 3 times 2 times 1, because that's what factorial means, divided by, well, 4 minus 3 is 1, and then r factorial, that's 3 times 2 times 1, and I like to do fraction math. I notice that these all cancel out, and I get 4. And if you look in your little box, when n things, 4 things taken 3 at a time, 4 things taken 3 at a time is 4. Okay, we're just going to do like maybe 2 more, and then I'll let you guys, you can fill out your own chart at home. But basically, if I want to find 5 things, so 5 things taken, what did I say, 2 at a time. 5 things taken 2 at a time. I know I should get a 10 from that. Let's see if I do. So it's 5 factorial. Comes from here. 5 times 4 times 3 times 2 times 1. And then 5 minus 2, because it's n minus 2. 5 minus 2 is 3 factorial. 3 times 2 times 1. And then 2 factorial, because that's r. Now you'll notice that the 2 and the 1 cancel out. All right, I think I made the 3, 2, 1, and this 3, 2, 1 cancel out. This 2 times 1 is 2, and it cancels with the 4, and I get 5 times 2 is 10. Let's do another one. This would be the combination of 7 things taken 5 at a time. So that would give me whatever number goes where the 7 and the 5 are. I think that's supposed to give me a 21 right there. So let's see if I get that. So I'm going to go 7 times 6. Now, if you don't mind, I'm going to take a shortcut. I could write times 5 times 4 times 3 times 2 times 1, but that's going to cancel out with this 5 times 4 times 3 times 2 times 1. So I'm just going to not write it, if you don't mind. And this is 2 times 1. Okay, so 2 times 1 is 2. And that cancels with the 6, and I get 21. You can put these in your calculator if you're not comfortable with fraction math. So that is how I can get the numbers to fill out this table. So what we would have done in class, if we would have been in class, is you guys would have gotten comfortable figuring out how to get these numbers, and then you would have filled out your table, and then you would have talked about what's going on with these numbers. Discuss any patterns you notice as you're working. So some patterns I notice is there's a lot of 1s right here. I notice that there's a big bunch of 0s over here. I notice there's 2 10s here. And there's 2 35s here. And I noticed there's a symmetry of the numbers. I mean, you might notice a lot of different things. I noticed that, like, I got a 1 and a 1, and I got a 5 and a 5, and a 10 and a 10. Let's see if that holds true. 1 and a 1, 4 and 4 and 6. So please take some time and look at this and notice some patterns. This is kind of important. It's going to be Pascal's triangle. So 10-152, it says the triangular array at right is another arrangement of the number of combinations you entered in this table up here. It's known as Pascal's triangle. Copy the triangle and add several more rows. So you might have already heard of this triangle. It's a super famous triangle. It's an amazing triangle. It's full of patterns. It's a great triangle. And you're going to use it it's going to become useful for some of your math, especially expanding these kinds of binomials right here. So just take a look at the triangle. It starts on the top with a 1, and then it's got a 1 and a 1. And then some of you might notice the patterns that there's 1s along the sides. You might notice that it goes diagonally 1, 2, 3, 4, or 1, 2, 3, 4, 5. The thing I always notice about it is I can get the next term by going 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So like this 5, I can get it by adding the two numbers above it. This 10, I can get it. So that's my favorite thing about the pattern, because then if I want to expand it, 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 15, 6, 1. So is that what they wanted us to do? Yeah. How many? So there's a lot of different patterns. You might find more patterns than the ones I said. Discuss your patterns. The single number 1 at the top of the triangle is called row 0. Now label the rows of your triangles to row 10 and describe how to write the numbers in any new row of the triangle. So yeah, I could keep expanding this. I don't have enough room on here. I actually brought my big triangle with me. So here's my big triangle, and I could get row 10. So they told me the top one, this is row 0. So that would make this row 1, row 2, row 3, 4, 5, 6, 7, 8. This is row 10, and you'll notice row 10 starts with 10. Well, I mean, they all start with a 1, but row 9 starts with 9. Get the idea? So that it makes you have to call the first row, row 0. So I can get more and more rows if I want to. 1 plus, that gives me 11. What's this going to be? 55. All right, do you get the idea? You can you can add the numbers and see all the little plus signs, and you get the next row. So this is saying, well, this is just giving you the answer to row 10. If you were to go ahead and keep adding onto this, like this would be a 7 here, and then 6 plus 15, what, like 21, 35. And it says each number is the sum of the two numbers to the left and right above it. So we're going to have, this is going to be a 2-part video for sure. I think I'll do 10-153 and then we'll start part 2. So 10-153 says, now consider what may appear to be a completely different problem, the algebraic expansion of the binomial expression a plus b to the n. Use what you know about exponents and multiplication to complete the parts a through d below. Write a plus b squared in expanded form. So I'm going to kind of go a little quickly through this. So to get a plus b in expanded form, I can do that one in my head because I just know that it's going to be, you take the first thing and square it, and then you go the first thing times the second thing times 2. But then when I want a plus b to the third, I don't have that one memorized. So I take a plus b squared and I write it on a multiplication box. A squared times a is a cubed. A times 2ab is 2a squared b. See what I did? It's a multiplication box. And then I can get, this is the expanded form of a plus b cubed. Sorry, it's a little messy. And then if I take this and multiply it in another multiplication box, which you can see this would take some time. If I do all this, right, I get a to the fourth. Well, there's my a to the fourth. And I'm not going to take the time in this video to do all this multiplication, but I would get this long expansion. Now, if I did it if I wanted to get a plus b to the fifth, I could take this and put it in another multiplication box and multiply it by a plus b again. Or I can use, yes, Pascal's triangle. It's amazing, but I can. Notice that the coefficients, do I have a good color? Let's see. Notice the coefficients are 1, 2, 1. And then this is 1, 3, 3, 1. I'm just taking the coefficients, the number coefficients. This is 1, 4, 6, 4, 1, isn't it? Look. 1, 4, 6, 4, 1. What? So this is ab to the fourth. These are the coefficients of a plus b to the fourth. If I want the coefficients of a plus b to the fifth, I can just grab them right off my triangle from row 5. It's going to be a 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. So I didn't leave much room. If I were to do all the hard work of multiplying this out, this is what I would get. 1a to the fifth plus 5. Now the a's are going to go down in descending order. Notice it went a to the fourth, a to the third, a to the second, a to the first. So it's going to a to the fifth, a to the fourth, a third, a, oh, oops, that plus sign doesn't go there, sorry. And then that's a to the 0. I'm not going to write a to the 0. Well, I'll write a to the 0 for you. Okay, and then the b's are going to go b to the 0, b to the 1, b to the 2, b3, b4, b5. Okay, and these are the coefficients. I have to start a new video. There we go. So what I'm saying is that I can find out I can expand something like this without multiplying if I use my Pascal's triangle. We'll pick up where we left off in part 2.